Okay, great. All right. All right. All right, Yash. Okay, so all right. So I would like to go over Spark today. As some of you are asking for Spark, then the votes for Spark are higher than the one for Scoop and Uzi. All right. And then we can discuss Flume and Uzi and Scoop. Okay. It doesn't make much of a difference. So this is for all right. So Spark is an exciting topic, and we would like to discuss more about Spark. And what I believe is that after this session on Spark, you should not need anything else. Okay? After this session on Spark, you should not need anything else. Okay? Oh, why does it create all these windows? All right. All right. Is everybody okay with me starting with Spark today? When I say that this this Spark course should suffice in understanding the basic concepts of Spark, and and that should build a strong foundation for your learning onto Spark if you are planning to go ahead with it. Okay. All right. So it's not the way we are covering Spark is not just a lip service. It's a proper hands-on session. Okay. So all of you be ready for the hands-on on Spark. All right. So what exactly is Spark? Some researchers came along and then they said that they can do a better job than MapReduce. Okay, so they wrote Spark. And Spark tries to utilize the memory instead of the disk. Okay, so Spark is a fast and general engine for large scale data processing. It's really fast. It's really faster than MapReduce. It's 100 times faster than Hadoop MapReduce in memory, and 10 times faster on the disk. It builds on the similar paradigm as MapReduce, and it is well integrated within Hadoop. Okay, so so Spark is not competing with Hadoop. Instead, Spark is just competing with Hadoop MapReduce. Okay, so it's an kind of alternative to Hadoop MapReduce, and therefore all the technologies which are depending on MapReduce, they are being also rewritten to work on top of Spark. For example, Pig is being rewritten, Mahout has been rewritten, and there were few more technologies which are being rewritten. Yes's question is, so one can build OLTP on Spark? Yes. All right. You can build an OLTP on top of Spark. All right. A general diagram. I hope everybody, since this class is going really good, I'm okay in covering more details because I'm happy that you guys are able to understand everything till now. And yeah, therefore I'm okay to go in a little bit more details. All right. So just like MapReduce, there are many technologies which are built around around Spark. Okay, so although we have a separate Spark course, but if you are able to go through this, that other part you would not need you would not have to go through much. Okay, so basically Spark is a kind of computing engine. Spark is a kind of computing engine. It does not have its own storage, but it can read from HDFS, HBase, Hive, and other new file systems such as Tachyon. Tachyon is kind of a high availability file system like HDFS. Okay, so Spark is running on top of the way Hadoop runs, the way MapReduce runs on top of Yarn, right? You remember those resource manager and everything. So the way MapReduce is running on top of Yarn, in the same way, Spark also can run on top of Yarn. Okay, and that's what it does. So the way MapReduce was reading data from HDFS and making the code run near the data, in the same way, Spark also can read from HDFS and run code near the data. Okay, and Spark runs on top of Yarn, and similarly, MapReduce also runs. But interesting part with Spark is Spark not only runs on top of Yarn. Okay, if you are on EC2, if you are on Mesos, then also you can use Spark. And most interestingly is if you are setting up a new cluster and you don't plan to install Hadoop, okay, and you don't even plan to install a resource manager like Mesos. Mesos is a resource manager just like Yarn, which basically takes care of which computer is free, which one is busy, how much load is on which one. Okay, so Spark makes it possible to run something called standalone mode, meaning it comes with its own cluster manager, internal cluster manager. So all you have to do is install Spark on all the machines, start Spark, and then it will start functioning along with other machines as long as all machines know about each other. Okay, so basically Spark comes with its own standalone as well. So that's how Spark runs on top of Yarn, meaning and And also please note that if you are running Spark on top of Yarn, you do not have to install Spark everywhere on the cluster. Okay, all you have to do is give the jar, Spark jar, to Yarn, and Yarn will start running that. Okay, because Yarn is capable of running anything on the cluster. Okay, as long as you have built the application for Yarn. All right, so once you have done that, the so once we have understood that Spark can run on top of these various kinds of resource manager and can read from and lots of file systems available as of today, and users can interact with the Spark in many forms. The way we interacted with MapReduce via Pig, via Hive, and some more tools. In the same way, users can talk to Spark via SQL, via Spark R, via Java, via Python, and Scala. All right, and so these are the various languages with which users can talk to Spark. All right, and and the other libraries which are the provided by Spark are streaming, MLlib, and GraphX. There are some more libraries which we can go into later. All right, sounds good to you? All right, so yes, Mamta, hi, and all right. So basically, whether you know Python, whether you know Scala or Java or R or SQL, you would be able to talk to Spark. All right. Just that there are some more libraries such as streaming library and MLlib library and GraphX. These libraries come only for few. These libraries are not uh, available in all languages yet. Okay, but these libraries are available in Python and Scala and Java, not in R or SQL. Okay, so therefore, if you really want to use these library, you might have to use Python, Java, or Scala. All right. So although we have already installed Spark on our cluster, but if you want to install on your own cluster, all you have to do is first find out the version of Hadoop which you are using, and then download a corresponding version from the server, from the Spark servers, and then extract it and put it into the library. This step basically moves it to a user lib, and afterwards you can make the name look nicer by giving it another link. Okay, and then you can log in. The most important part is that you can run PySpark. Okay, PySpark is a interactive cell. PySpark is an interactive cell on which you can type the commands and it will work well. Okay, so PySpark is an interactive cell just like Pig or any other interactive cell. And and this PySpark is basically a Python shell. Okay, so let's have a look at it, and we say hello to the command line, and then we will get into more detail. All right. Abhay's question is, what are these libraries for? Okay, I think I should have dived a little bit more. Okay, so Spark streaming, which we will cover later. So as a user, if we have to process a lot of amount of data per second, you remember the third V for velocity, second V for velocity. So when the data has a lot of velocity and you have to churn the data, say per second, imagine doing the word count on every second of the data that is coming to your server. Okay? So if you have to do this kind of real time work, then you can use Spark, but Spark, by the way of Spark streaming. Okay, Spark streaming is nothing but a small library on top of Spark. Whenever you talk to streaming, it basically creates data in HDFS or in RDD, and then you interact with it. Okay, we will go into the details later. Then the second library is MLlib. MLlib is a machine learning library. Is a machine learning library, meaning if you it's a machine learning library in the sense that the complex works such as generating recommendations and doing the intelligently guessing what is going to be next, okay, based on historical data. If it can guess what is going to be next, okay, that is MLlib. All right, we will talk about machine learning a little while later when we talk about Mahat. And then there is GraphX. GraphX is a graph manipulation library, such as, let's say you're building some kind of a Facebook and you want to give recommendations to friends. All right, so that is GraphX. Mamta's question is Spark R is same as R? Yes. The interesting part of Spark R is that you can utilize R's libraries on Spark. Okay? All so the quality of Spark R is that it can run most of the R code. Okay? All right. So Spark QL it has been replaced with Spark SQL. It's called Spark SQL. Okay, and basically it makes it possible to churn data using Spark SQL. Okay, all right. Now, my next question is: does Spark requires any special data node or same as Hadoop? It will work on the same as Hadoop. All right. With the, so although Spark is happier when individual nodes have higher memory. Okay, you will see that later. Good. All right. So that was a very high level introduction of what is the ability of Spark. Okay. So Spark is an engine which can do the computation. It's in very simple word, if somebody has to ask me, it's basically an engine which can help you do the computation. Okay. You give the code to Spark, it will run on various nodes and do the things. Okay, so Spark is a distributed computing engine. Now, you can invoke the computing engine by the way of talking to it in terms of programming language. You can give it a code and let it do, or you can go a little higher and utilize libraries, or utilize some other high level language such as SQL and Spark R. All right, so let's jump in. I would like to show you the starting of this. So if you go to my courses, you will see. All right, let me log in. So, all right, so this is my login. All right, so this is the console, and is the font okay now? So the way you run Spark is we will be talking to Python via Python, this part, okay? This is something which we are going to talk about, and yeah. So to run Spark in Python, you have to say PySpark, and you will be welcomed with by a, what do you say, a nice character art, okay? So from here, you can start interacting with Spark. Okay, so it's same as a Python command prompt, except for two more variables for you. One is SQL context, and other is SC. Okay, I will. If, in the same way, there is if you run Python on your machine or in our CloudX lab, if you want to practice Python, you can open Python console like this, and anything you do here, okay, is a code being executed by Python. All right. So similarly, if you run PySpark, it's actually this, what do you call, the Python console, Python interactive shell. Okay. What is Python interactive shell? It's a command prompt on which you can write your code and it will immediately execute it. The way I said 1 plus 2, it's nothing but 1 plus 2 is an expression which got evaluated immediately. We could go a step further and try to write little complex algorithm logic. For example, I can say this is my function, okay, and what it does is it returns x into x into x cube. Okay, now I can call this function, okay, with 10 and it has done the cube. Okay, so you can see that those who are not aware about Python, that you can do the rapid prototyping or quick prototyping or quick coding on the shell. Okay, if you gather all of this code and put it in a file, then you can run it as if it's a normal script by saying python space my file, and it'll run that code. Okay, so the way pig was talking to us and we were typing the command and it was interacting, in the same way we are talking to Spark right now. All right, and this shell is basically giving us the whole ability of Python combined with Spark. Okay, so it's a Python shell containing two more objects like SC and Hive SQL context. Anything you do with SC, you will be interacting with Spark. If you do not touch these variables, SC and SQL context, you are not talking to Spark. You are just talking to Python. All right. So right now, when I say my F100, I'm not talking to Spark. I'm just talking to usual Python. All right. I hope I've not confused you. So right now, so this PySpark is nothing but Python console on which you can type any Python command, or you can write anything here, and that will get evaluated immediately. Plus two more objects, SC and SQL context. So these two objects are your gateway to Spark. These are two objects which are your gateway to Spark. If you say sc.text file, you'll be loading the data from HDFS. All right. So I can say my big file. You remember this file saying sc dot text file. Okay. Since our Spark is running on top of Yarn, any file name I provide to Spark, this command, any file name, it'll try to derefer it from HDFS. By default, it'll try to derefer it from HDFS. So you can see that I'm saying data slash mr slash word count slash big.txt. You remember this file? We use the same file for our word count in MapReduce. Okay, this file is lying inside data mr word count folder in HDFS. Okay, so you could say my big file. So what did we do? Just I did a quick thing. Right now we are interacting with the Spark by the way of SC, by the way of this object provided by Spark. So I'm saying sc.text file, meaning please load this text file into my file. Okay, and then I'm saying my file dot collect. Okay, or my file dot tick. I'm saying give me 10 lines of that file. Now you can see that I got an array of 10 lines. Alright, do not worry even if you did not get it. Okay, I'll explain again. So right now we are on Spark prompt. It's basically a Python prompt plus two more objects. Okay, these two objects, SC and SQL context, are your gateway to Spark. And the moment you touch any of the objects, you are interacting with Spark. So you can see that I said sc.text file. That means I'm talking to Spark at this moment. Okay. And when I say big file, then I'm talking to Spark again because big file is this object is given by Spark. All right. So it's a very great combination because if you guys were trying to use, say, pig, in case of pig interactive shell, it's little limiting. It's little limiting. For every extension you have to write pig UDF, which is a long cycle, which does not give a great control. Okay, so here you can keep on writing in your usual code and interact with Spark Spark very uh, rapidly. Okay, very immediately. All right, so just now we what we did was we loaded the file, dumped the data. That's it. Okay, I'll show you a lot of things, and the interesting part is that for preparing for these courses I do not have to copy paste my code. Okay, instead I can type it quickly because it's not that much time consuming. Unlike, you remember my Java session whereby I had pre-prepared the project because it would take long time to do something and demo you something. Okay, therefore this prompt gives us the ability to do things really quickly. All right, so this was our quick introduction to Spark. So we started PySpark like this. There are other commands, so you could actually, if you want to try it out, let me take out this prompt in another window. Okay, so yeah, if you want to say run in a Java code, you can run the Java code as well. Okay, so you could say Spark shell. It'll give you Spark shell will give you the prompt which works on Scala. Okay, this is a Scala version of Spark. Okay, Scala is another language like Java or Python. All right, so you can now talk to Spark from the Scala prompt. Okay, so if you are creating a Java code for Spark, you can say Spark submit and give the jar, and it'll run on Spark. All right. So that was a quick introduction to getting started. All right, a little bit concept because this is the basic concepts and we need to understand it. All right. So the most important concept in Spark is this concept called RDD. It's probably the most important concept. The reason is that everything, whether MLlib, GraphX, Spark Streaming, everything revolves around RDD, Resilient Distributed Dataset. So this is the heart of Spark. So basically, the Spark guys came up with an idea or a data structure saying, let's create a data structure called which looks like a big array of values. And this array of values, the property of this array of values is that it is distributed. It's spread across multiple machines. So that was the idea behind RDD. Let's create a big array which is distributed across the cluster. Okay, it's distributed across the cluster. Some elements on one, some elements on another, some elements on some other machine. Okay, that was the most important part about the resilience distributed data set is. Okay, and also each individual machine, in case they go down, the same RDD, whatever, same section of the array or of the list of values, same section which was on one machine. Okay, actually that each individual section is called partition. If a partition goes down, it gets recreated on some other machine. Okay, coming back to it, so basically a resilient distributed data set is something most important idea in Spark. Okay, you can think of it as if it's a big list of values, a big array. Internally internally that array is divided across the cluster. Okay, so anything you do with the array, you are talking to the array on the all clusters. Okay, so that's where the whole magic begins. Just like if you remember our big discussion, there were data sets and we were operating on data set. We were saying filter this data set or group this data set, join this data set, and so on. So basically, the Spark guys got the idea of data sets from the pig. Okay, so the way pig has the idea of data sets, similarly, here they took it to the next level. And they said that let's have a generic data set, okay, which you can operate with any programming language. All right. So an RDD is basically just like pig, it's an instruction or it's a mapping saying this data, this particular partition will load the data from these blocks in HDFS. That's what is happening. So here this is basically a mapping happening. When we say load my data from HDFS into Spark, what exactly are we saying? We are saying that we're basically creating a mapping. So partition 1 maps to this block from this location to this location. Partition 2 is composed of two blocks, one from this location to this location, and other from this location to that location. So basically, an RDD is a mapping of the actual location of data to a partition. Okay, so this is totally hidden from the user. This is totally hidden from the user, and but user can, if user wants to, poke around with individual partition and want to control individual partition, they can do that easily. Okay, so this RDD, instead of being prepared every time, it can be kept in the memory. Okay, by saying called persist. This RDD can auto recover from node failures. So imagine that these are how many partitions are there right now? Quickly, anyone? Yeah. So it has how many partitions? Correct, Biswa. It has four partitions right now. Okay. So first partition from some block, second partition from some block, and so on. All right. Each partition would contain many elements. Generally, partition is just kind of an array containing values. They can have different data types. Okay. You can create any kind of data type in the partition. Okay. And there is a special data type for key value, meaning it provides some operations which are specific to the key value pairs. Alright, it supports two kinds of operations. One is transformation and other is action. Alright, we'll talk about this. And also RDD is read only. Just like if you remember in PIG also, we always created a new data set. We never modified existing one. In the same way, RDD is read-only. We can take an RDD and create a new RDD. We cannot, say that delete these elements from this RDD or change in place. No, we always create a fresh RDD. All right, an RDD can either be prepared by loading file from HDFS. This one we have already demonstrated to you. Okay. So we can load the data like this or like this. I think this will also do. All right. So let me just again launch PySpark. Okay. So right now we got into Spark. Then we are saying lines equals to this. Let's try to take. Will it work? All right. All right. It says that the short circuit could not be loaded. All right. Uh, let's let's try to load it. Looks like it's not loading. What is the port number on which port number of name node? Alright. Okay. Let's see if it can work. How come it has stopped working? It's trying to connect. Mm-hmm. It's not letting me connect. Never mind. Alright. Never mind. I'll just. Okay. So I can simply even say this and it should load the file. Okay. Lines dot take. You can see that we were able to load the data from HDFS. Okay, because by default it connects to the HDFS and load the data. So when we say this kind of syntax where we are not mentioning anything but only the file name, it will talk to the Spark if we are running on a Spark cluster. It will talk to the HDFS if we are running on a Yarn cluster. All right. So we were able to successfully load the data. In case you want to convert a local variable into RDD, this RDD can be prepared out of anything. RDD can be loaded from HDFS. RDD can be created out of a local variable. Okay, I'll show you what does it mean. Let's say we have a big array. Okay, we say that what do you call say a equals to 1, 10, 10, 20, 30, 40. Okay, what exactly is happening? All right, so you have this. Okay, so this is our local array. In Python, we are creating an array containing these 5 values. Okay, now we can convert this array into an RDD. Okay, meaning it will be get distributed over the cluster. We can simply say sc dot parallelize. So we can say ARDD equals to, this is ARDD is any name, and we could say parallelize. All right, so okay, not like this. We could say, actually this thing is disturbing. All right, so let me just define it again. So this is my array A. Okay, I'm saying ARDD equals to sc dot parallelize A. Is my cluster okay? Let me just check if it is okay. Cluster seems to be good. Cluster seems to be good. All right. It is just that our old process on Spark still running somewhere and bothering us. Let me just log in again from fresh. So PySpark, we started the Python interactive shell. Okay. Now we are saying this is some array of values which we want to keep here. Okay. Then this is a normal array. This is a normal array. We can access any element of array and we can do anything with it. Okay, using our local programming language, which is Python. Now, the next thing we do is we take it to the we distribute it and convert it into an RDD. And how do we do that? Using Spark context. So we say a RDD, this is some name I'm giving. We could also say my RDD equals to sc dot parallelize, okay, sc dot parallelize. Okay, now this my RDD is your gateway to this RDD which is created around this array. Okay, if you want to collect all the data back, you will have to say my RDD dot collect. Then it went to all the clusters and brought the data back to you. You can see that it brought the data back to you. That is something which is very important. Okay, so we parallelized, meaning distributed our local array on the cluster, okay, by saying sc.parallelize, and we collected it back using collect. Okay, that might sound totally useless, but we will go into more details and then you'll have more clarity. Okay, so we could create the data, the RDD, by either from HDFS. When we use this command saying my RDD equals to sc.text file and the file name, it talked to HDFS, loaded the data, okay, such that each element of RDD is a line. Mahesh's question is, what is the criteria does it use to distribute and where does it distribute? It distributes on the yarn nodes. Okay, so remember the resource manager and the various nodes we have in yarn, it distributes these values on those nodes. Okay, so the question is twofold: what criteria does it use to distribute and how does it distribute? Okay, answer to first one is it equally distributes. Okay, and the second part is where does it distribute? On the yarn cluster, on the nodes of yarn cluster. Okay, does it store it on the disk or in memory? Mostly in memory. And initially when we are saying sc.parallelize, it's basically taking it from one memory to another. Okay, and if we are loading from disk, in the second line when we are loading from the disk, or here when we're loading from the disk, what's happening is taking the file and creating a mapping between the file and the actual sections of the array. All right, so that's how it does. All right, now we have created RDD successfully. Now what? Okay, so the idea about RDD is we run all the logic on top of RDD. Okay, the way we said filter in pig or group by in pig, or we executed various kinds of things on top of pig, in the same way, we execute logic on top of RDD. Okay, so there are two kinds of things which we can do with Spark RDD. One is called transformation, other is called action. Okay, a transformation a transformation is note to the system saying, hey, my new RDD should be created out of this existing RDD in the following manner. Okay, so a transformation is run on every node, every partition, every node separately again and again. Okay, so you can see that a transformation is being executed on each section of the RDD, and it will create a new RDD. Okay, so one RDD gets transformed into another RDD by the way of a transformation. Okay, and also the execution is lazy in the sense that when we say transformation, it doesn't happen then and there. Instead, when an action is executed, only then a transformation is executed. Okay, you remember our spark, sorry, our pig again. I'm taking the analogy from pig because that's the closest way to look at spark. In pig, when we say dump something, only then all the things on which that something is depending upon gets executed. Okay, only when we say dump or store, only then all the things on which this particular data set was depending would get executed. In the same way, when we run an action, a transformation will get executed. Okay, I'll show you, then you will get a more clear clarity on what exactly am I talking about. Now, so here you can see that a transformation takes an RDD, converts it into another RDD. That's it. That's it. That's what transformation does. Okay, transformation is done by couple of functions. Okay, there are many functions which lie under the criteria of transformation. There is first transformation called map. Okay, map basically translates each object of an RDD into another object of an RDD. Okay, of the new RDD. So it returns a new distributed data set which is created by passing each element of the current RDD by passing through each element through a new function, through a function. Let me show you. Let me show you. I think this is best done by the way of demonstrating. So what does my RDD contains? Okay, my RDD right now is created out of this array. Okay, is everybody with me? My RDD dot collect. You can see that the this is what is there inside that RDD. Okay, every time we are saying collect, it's bringing the data back to you. Therefore, you do not use collect in the production. Okay, because it is going to overflow your screen, the memory of this local node, and so on. Okay, so this RDD, let us say that we want to translate each element of the RDD. What is the first element of this RDD? My RDD, quickly, let me. Okay, what is the first element of this RDD? That's right, it's 1. So let's say we want to translate it into, say, 2x plus 1. All right. So we will multiply each element of this RDD by 2 and add 1. Is that okay? So we want to do this. We will say y equals to 2x, right? This is what we want to do. So for each element of this RDD, my RDD, we want to generate something which contains the element, which each element is going to be twice the previous one added by 1. Okay, so let's create a function, define my function, let's call it some name, where I'm passing an argument called x. Okay, I'm just creating a function right now. Return 2 into x plus 1. Okay, so my function, if I say 10, will be 21. Good. All right, so x is just an argument here. Midley. All right, the moment, so we want to apply this function on every element of this RDD. Okay, so let's say and how do we do? We use something called map transformation. Okay, let's not talk about the map in MapReduce. This is a little different kind of a map, the true MapReduce. This is true MapReduce coming from the functional programming language history. Okay, so I'll say my RDD dot map, and then I'll give the pointer to my function. Okay, I'm passing the handle of my function. I'm giving the name of my function to map. That uh, hey, can you execute this function on every element of this RDD? So this is statement. What does this mean? This statement means I'm telling to Spark that can you take my f, can you take my f and run it on every element of my RDD. This is what it means. Okay, and running on an element, what does it mean? We pass the element as an argument to this function, and whatever is the output, it is gathered, and it is creating another RDD. We are saying take every element of my RDD, pass it through my f, and save it in my RDD1. This is what it means by running this function. Okay, so now let's have a look at it. Okay, if I say take, say 5, okay, it's giving me first 5 elements. Or if I say collect, okay, so you can see my f1. All right, so all right, I'll write it for you. Okay, so my RDD.collect contain my RDD was basically formed out by parallelizing an array which was this. Then my RDD1 was, okay, so you could see here, where is my function? Here is my function. All right, here is my function where I'm saying that, here. Okay, so you can see that I created a normal function in Python called myf, and then I code it in such a way that whatever argument I pass to it, it'll return twice of that added by 1. And then I'm running it through map. I'm saying, please run this. What does this statement say? This is the most important thing to understand. I'm saying I'm saying take my function my f. This is the function I'm passing to it. I'm giving my f function to Spark and telling Spark that could you run my f on every element of this particular RDD. Okay, so effectively, how would it look like? How would it look like? It will be my f being executed here, okay, and my f being executed on second element, okay, and third element and fourth element, fifth element, sixth element, seventh element. Okay, so my f being executed on every element. Sounds good to you? Now you can see that we took a function, and this execution of my f is going to be done on the all nodes of the cluster. Okay, so we, instead of carrying the data, if you remember, the way we used to do is we pass the data to a function. Here we are passing function to our data. My RDD is the data and my f is the function. So we are taking function, we are taking the logic to the data. This my f goes to every node and execute everywhere. Okay, and whatever is generated goes into another RDD. All right. Now, Biswa's question is, can it be done only for specific elements? Good. That means we are ready to move on to next. Okay. Midli, I hope you got the answer by now. Was he able to answer your question? Great. Great. All right. Any doubts about it? All right. This one, the diagram looks little ugly, but if you look at from here, it'll be more clear. All right. So there are, the first transformation we covered was map. Then there is filter. This is answer to Biswa. So basically, if you want to just pick few elements, then you can create the filter. Now, instead of writing SQL or writing an expression to qualify, saying filter all the elements where a equals to greater than blah and blah, here it's allowing us the infinite flexibility. Because if you write an SQL or something, you always have this limitation. Okay, here it's infinite. You are given the infinite flexibility on filtering on any logic. Okay, so instead of passing a condition, you pass a function. And this function is your kind of agent, your representation in the logic, saying that please run this function, and if this function says true, then put this out data in the output. If this function says no, don't put this uh, element in the output. What does filter do? It takes the elements of one RDD, creates another RDD if this qualifying function allows it. Okay, let me show you what do I mean. Let us say out of this, okay, we want to figure out what numbers are divisible by 3. Okay, so out of my RDD1, I want to say define is divisible by 3. Okay, is divisible by 3. I'm creating a function in Python which returns true or false. Okay, if, so here I'm saying if x percentage 3, all right, if x percentage 3 equals to 0, percentage means remainder, as in when I divide x by 3, what will be the remainder? Okay, I'm returning true, else I'm saying return false. Good, I'm saying return false. Let's try to do it. All right, let's try to execute this. Where is, all right, now we can define our function. Let's test it out. Is it working fine or not? I'm saying is divisible by 3, 1, false, 3, true, 0, true, 9, true. Perfect. If I say 19, it is false. Alright, so we just created a simple function called is divisible by 3. Now we'll take we'll we'll say my RDD1, or we call my RDD2. Okay, we call my RDD2 my RDD1 dot filter, and I pass the function called is divisible by 3. Okay, now you can see that I'm passing the function. I'm not executing the function. I'm passing the function. I'm handing over my function as if it's an argument. It's like a data, as if I'm giving it to somebody. Can take this function every time you are in doubt. Just ask this. It's like that. Okay. It's very important to understand that we are passing the functions because we all have this fear of pointer to the functions, okay, because of the C programming language. So here, let's not get into the pointer to the functions. Here, let's talk about, it's like a logic, it's like a calculator, it's like a something with which you can give the data and ask it. Okay, so that's my function which I've defined. Now my rdd2 dot collect, okay, you can see only those elements which which pass the criteria, only those elements which are divisible by 3 are kept in the output. Okay, so all we did was collect. Sounds good to everyone? All right. Abhi's question is, what about function having multiple parameters? Important part is that only one element at a time will be kept in this output. Okay, only one element at a time will be given to your function. Okay, imagine, let me try to answer Abhay. Okay, let's say we have an RDD called R. Okay, I'm just saying R1. Okay, I'm saying sc dot parallelize, parallelize. Okay, and it has got two coordinates. So it has got two values, say 2 comma 3 and 4 comma 5 and 6 comma 7. Okay, so every element is a, this is a tuple is like a small object. Okay, so here when I'm saying sc dot parallelize, I'm passing the tuple. Okay, in this case, in this case the in this case if you're filtering, okay, or let's say I'll say, okay, so in this case, let's say this represent x and y, and we want to pick only those elements out of this where the second element is smaller than the first one. So we define a function where we have x and y, okay, and then say if y is greater than x, return true, okay, else, or we can just simply say return false. Let's try it out. Is it working or not? Okay, my function f 4 comma 5 true and 6 comma 7 5 is false. Good, so the logic is working. Now let's try to see what happens in these cases. So R1 is RDD containing each element which is non-trivial, which is non-simple. It's complex. It contains an object which has two values. All right. In that case, so it's basically a tuple which is being passed. Now let me try to see if it works. If it doesn't work, then we'll have to do something else. Okay. So we'll say r1 dot filter. I'm passing my function called f and see if it works or not. It says that there are, it takes two arguments but one is given. Okay, that means that filter expects a function which only takes one argument. Okay, so if you have to emulate this, what you have to do is we have to say v, okay, we'll have to say x y equals to v. Okay, we are converting in one tuple into the individual values by ourselves. Okay, so now we can execute this function by passing explicitly a tuple. All right, now try to execute the same thing. Okay, where are the values? Yeah, all right. I hope I'm not confusing you, because some things may be very obvious to me. Some things may be obvious because I have gone through it. They may not be that obvious to you, so feel free to ask questions. Okay, all right. Now we are able to do this. Okay, all right. So what I did was basically, all right. Okay, so what exactly is happening in all of this? All right, first let me try to explain what I did differently. So any filter function you define has to have only one argument. Okay, you can cast it into whatever you want at later point of time, or you can split it into whatever you want. You can do anything with the individual element at all. Okay, but the filter function has to have only one argument. All right, that's the answer to Abhay's question. All right, if we go with your function, it should return true or false. Correct? Yes. How it's returning the match element. So that's the role of filter function. So this function f, okay, is returning true and false. If you see f, and I'm saying 2 comma 3, you can see it's returning true. All right, it is the job of this filter function, okay, it's the job of this filter function, or it's the job of Spark, that when somebody is asking for filter, it will take that function, the filtering function, and execute this filtering function against every element of RDD. Every element of RDD. And in case this function returns true, the element goes in output. If this function says false, the element doesn't go in the output. Okay, so that's what is this all about. All right. Was able to answer your question, Midli? Brilliant. All right. Now moving ahead. Similar to that, you have flat map. Okay. What does flat map do? So far, what we saw was the map function, the function which we pass to map, is supposed to take one element and is supposed to return only one element. Right, the map function takes one element as argument and returns one element as output. Okay, no matter what we do, the number of elements in the input RDD and output RDD in case of map will be the same. Okay, now, let us say you want to translate one element into multiple. For example, you want to break down each line into words such that the RDD is composed of words, so that when we apply filter function, the filter function is applied on word, or any operation is applied on each word rather than each line. We want to translate a line into words. Okay, we could split it, but again we want to create an RDD such that each element of RDD is a word. Each element of RDD is a word, and that's only possible by using flat map. Okay, so let me see if we have already created the, okay, lines is not defined. So let me try to create lines, and I can actually quickly do most of the stuff in the following manner. So this is lines, we are loading lines in the as the data. Now what will it do? Lines will be composed of a big array where every element is a individual lines. You can see this quickly here. You can see lines dot take. So is take 10 brings the RDD back to the node from where we started. You can see here the U represents the string in the Unicode format in Python. Okay, you can see that each element is like, this is your RDD elements. Each element, it's made up of lines. Let's say you want to break it down into words. Okay, what you do is we define a function called two words. I'm just creating any function. You can write anything you want. Okay, this L is an argument. Okay, and I'm saying return L dot split. If you do not pass any argument to split, okay, also you can test quickly on here on the console whether it's working or not. You can see it has broken this string into an array of string. So we created a function called two words which takes a string as argument and return multiple values in the form of an array. So we are returning an array by passing a string in the argument. Now we could say words RDD equals to lines dot flat map. Okay, we are saying flat map, and then we're passing our function called two words. All right, so what will it do is whatever function you have defined called two words, it's going to be executed on every element in this RDD, and whatever is the result, it's capped in the output. Okay, so it says two words is not defined. I have not defined the function yet, so let me define the function now. And okay, words RDD dot take. Now you can see that now this array is composed of each word. You can see the is one word, then comma, then project, the comma, Gutenberg, and so on. All right, makes sense to you? Abed's question is, how do you clear screen in PySpark? You can press Control L. You can press Control L. All right. Were you able to do that? All right. So this thing worked. Okay. Now, okay. Now, next thing is, so we were talking about flat map. Similarly, is group by key and so on. Group by key will group the data set by a key, and then you could go with each group and count it. All right. All right. Now we want to talk about something called an action. Okay. So the way we had dump in pig or store in pig, whenever we said dump in pig, every time it executed the full chain of commands. Okay, it executed full chain and gave you the output. In the same way, in Spark, there are many functions called actions, which when executed will start the processing. Transformation Transformation are not executed immediately. Spark makes note of it. If they are executed immediately, then Spark would not be that performant. Okay? Why? Because when you execute an action, Spark has luxury of combining multiple things together and figuring out that which one is more important and which one is not important. Okay, so action is more like executing a program. Okay, so far Spark was just, so it's like a waiter came to you and you told all the instructions. Okay, that's transformation. You said, okay, we want this, we want this, we want that, and so on. And then we said action, and then the waiter will go and do the work and bring the food, and that's it. Right, in the same way, here also in case of Spark, we tell all kinds of details to Spark in the form of transformations, and then we say action, and then actions execute all the things that are needed. Okay, so important thing is that this gives luxury. This gives us the let me put it in the right way. So imagine that waiter was executing everything as and when you said. Okay, you said bring water. The waiter ran away and brought water. Now you wanted something else. Okay, so that's not optimized. Instead, if you just tell the waiter that get us 3 glasses of water, and we want this, we want that, and then you say now you can go, we are done with the order. Okay, then he can optimize and bring the things together which are needed, and so on. So that is the benefit of having this lazy evaluation. Okay, that is the benefit of having lazy evaluation, because otherwise Spark would not have luxury to optimize. Okay, therefore this idea of transformation and actions is quite valid when the work is bigger. Had the work been smaller, it could not have been optimizable. Okay, therefore it's important to understand that this lazy evaluation is quite an important task, be it pig, be it spark, or be it other systems. Okay, unlike SQL where we type the command, a single SQL gets executed immediately and gives you result. It doesn't allow you the luxury of translating one data set into another, and do lot of steps and then execute all of them. Okay, so here also it's the same thing. All right, so actions are actions which do something, which make things happen. And mostly actions, not mostly, all the time, whenever you do action, the data from the cluster goes back to the node from where it was executed. So while loading of a file, parallelize or text file, loading of the data, convert a local data or any other data into an RDD. An action converts the data back to the local value. Okay, so action takes the RDD and does something with it, converts it into non-RDD. Okay, while text file, parallelize, those things prepare an RDD. So this is an important aspect of an action. Yes, execution of a function like reduce is an action. The action which we have been using so far, the action which we use so far is the collect. Collect take is an action. these things make happen. This is what makes things happen. So if you see when I say lines dot take 5, take is an action which executed the computation of DAG and everything. Okay, while we did say, for example, we said words.rdd, it did not do anything, it just made a note of it. It's waiting for us to do an action, only then it will do something. Okay, so in the same way, when we say r1 and r1 dot collect, it executes the whole flow. Okay, so collect and take were an action here. Is that clear, Midhili? Biswa's question, alright? Biswa's question is map used for numeric data and flat map for text data? No. Map means, okay, map means single value gets passed to a map function. Okay, it returns a single value. Okay, while a flat map converts into multiple values. Okay, so imagine, we had an RDD. So here lines is an RDD which contains, lines is an RDD, lines is an RDD of lines. Okay, uh, okay, meaning it's like a big array of it's like a big array of individual lines, right? Now what we want to do is we want to break it down into words. That's why we did that. Now imagine this one. I'll go back here. Let's say we have this RDD and we want to convert this RDD. In this RDD, first element is this, second element is this, third element is this. Let us say we into want to convert it into something like this. This is very important. Okay, let's say we want to convert it into this. Okay, into an array of elements like this, so that the individual unit on which we will operate becomes numeric from a group of values. Right now, each element of this RDD is a tuple. Okay, we want to break it down into this. So what we'll do, we'll define a function f. Okay, what it takes something called a tuple, and then we will return tuple 0 comma tuple 1, and we will return it like this. Okay, we are saying not like this, we will return an array. Okay, this is supposed to return an array. Now we'll say r2 equals to r1 dot flat map, and use this function to do the flat map. Okay, so we defined our r, and then we defined our function. Okay, all right, what happened to this guy? Okay, so we could say r2 dot collect, and all the values have been collected like this. You get my point? So when we want to basically convert one value into multiple, then we use flat map. Okay? Map only translate one value to another value. Filter decreases total number of values, while flat map increases total number of values. Right? There are many actions: reduce, count, collect, and take. We'll discuss it after the break. All right? All right, I'm back. Should we start now? All right. Uh, Yash, Abhay, Bishwa, Mahesh, Mamta, Murli, Midli, Prezi. Should we start? All right. So today we are discussing something very important, which is related to the Spark. Okay. So in the first half we talked about the transformations. Now let's talk about actions. Okay. So actions bring the data back to the node, or so actions do two things. One, they when you execute an action, it brings the data back to you, or it takes out the data from RDD into some file system or somewhere. And the most important part of an action is it makes things happen. It makes things happen. Okay. The transformation happens only after the action. All right. There are many kind of actions. The one collect and take, we have already seen it, used it multiple times. Collect brings data to you. Take brings the data to you, but only few elements. While count counts the data, counts the number of elements in the RDD. Say we can say R1 dot count. You can see. All right. Okay. So the first one is something which there are many. Also, there are many more transformations. You should take a look at this API. There are many more transformations. If I go into everyone, it'll take a long time. Okay. Therefore, I'm only going through few. Rest is up to you. Okay. So there is a reduce function. What it does is it reduces the values into few things. Okay. Let me get my mouse so I can draw. All right. So reduce defines how to combine two values into one. Okay. How to combine two values into one, that is the role of reduce. Okay. Now your question would be, how would reduce so let me so reduce function converts the whole RDD into single value. Okay. While this function which you are passing takes only two arguments and converts it into one. Okay. Let's take a look at something more meaningful. Something more meaningful. Like for example, my RDD1, right? Did we have this now? Okay, it's not yet defined. Let's just define it. So we could say my RDD1 equals to sc dot parallelize. Okay, we are converting. What does parallelize do is it converts a local object into an RDD. You give an array and it will create an RDD out of it. Okay, creating RDD means it will take this data, put it on all the cluster, create partitions and all of it. Okay, now we are saying let's define a function called reduce. Okay, let's call it sum, sum. It takes two arguments, x and y, and it returns a single value called x plus y. So if I call sum on 4 5, we get 9. Okay, now the interesting part is total equals to, I can say, my RDD1 dot reduce, and I say sum. Okay, now does it make sense to you? Okay, so first question from Yashwant was, so Yashwant's question is, what does parallelize do? And yeah, so parallelize basically takes the local array, converts into RDD. Okay. Yashwant's next question is, but the same thing can be achieved by transformation. Not yet. You can't. You can't bring the data back to you using a transformation. Okay. All right. So now you can see that we are saying reduce. Reduce is converting two values into one. Okay. This function sm converts two values into one. But the interesting part is that this reduce will reduce the whole array into a single value. You want to check it out? Let's try to do this. Okay. Here. Okay. Now see. All right. Now you can see total is 26. Do you see some magic? Sum was only converting two values into one, and how come this reduce converted the whole array, a whole RDD, into a single value? How did it do the summation? Okay, you get my point? So you can see that sum was only returning sum of two values, while reduce returned the sum of all the values. How did it work? Yeah. So yeah, Midli, I think I made a mistake while I was saying reduce and two arguments. So it's actually the reduce function which we are passing that I was talking about. So reduce function sm takes two arguments. You can see x and y. It returns a single value. Now, reduce takes such function and apply over and over and over again till it's a single value. Okay, till it's a single value, and hence we are getting this. All right, so let me try to see if I can show you pictorially. Okay, imagine that imagine that imagine that 1 2 3 4 4 6 6 1 2 3 4 4 and 6 6. Okay, imagine it's this. Now, so this sum function, okay, this sum function which you see, it's converting only two values into one. Let me try to draw the sum function. Okay, let's say that this is our sum function which converts it into a single value. Okay, this is our sum function, and I'll just write sum, and it gives out some total of 2 1 and 2. Okay, so this is going to be 3, right? Now similarly, if you think of little bit as if this is being applied over and over again, you will see same function taken to all the nodes. The way I'm taking the same function to all the nodes, this is also being taken to all the nodes. Okay, so good. Now, what will be the value here? 7. What will be the value here? 10. And what will be the value here? It'll be 16, right? And so on. Again, the same function which we are talking about right now will be applied on 3 and 7, will be applied on 3 and 7, and we get a value. Okay, well, let me just make it a little. Okay, so yeah, what will the value here? 10. And again, same sum function is being applied on these two, and we get, in the end, we get 26. Okay, is it clear to everyone? So what did I do? I took a single function, applied over and over again on the whole array until the value turned to be a singular. Okay, until the value turned to become a single value. And that's what I did here. Midley, are you with me? Was I able to explain? Yes. All right. Any questions at this point? Okay. So the way we did here, you see, 26 came in a single shot, right? Same way we did it here. Okay. So why this whole drama about applying the same function again and again? Why couldn't we just get the whole array and do it in a single shot? We could have just iterated over the values and computed the sum, right? The reason is this approach of reduce automatically makes it possible to take code to the data. The function was sent to all the nodes, and all the nodes, the summation is being computed parallelly. Every partition is computing its summation parallelly, and then the output of all the partition is being combined again by the same function. So effectively, it's extreme distribution. The function is being executed all over the cluster by individual nodes. Okay, individual nodes themselves might have multiple processor, some of the elements being combined in one processor, some other elements being combined by the other processor, and all of this is only made possible by having this divide and conquer strategy. Some few parts of the array goes to one processor, other parts of the array goes to another processor, and all of them continuously and parallelly executing this function again and again, and the result of all of those being combined again using the same mechanism. This is extreme distribution. This is extreme distribution. All right, this is what makes possible, this is what makes Spark. Otherwise, if there is no distribution, there is nothing like reduce and filter or map, then you will always carry the data to a node and you will apply it again. Now these mechanisms like filter, flat map, map, and reduce make it possible to do the heavy distribution of the work. Some nodes applying reduce function on 10 elements, other nodes on 100, some other nodes on 1000, and so on. All of these are working in parallel. One node is not waiting for some other to finish. Only once one node has finished working on its things, then it will say that here is my output. Now I'm done with my work. Now you can combine it together. Result will take, although your reduce function, the overall computation, you will have to wait a little bit, because let all the nodes finish the reduce, only then you can further combine their outputs and get the things done. So this is like a extreme distribution of work on the whole cluster without you worrying about all of that magic, how to transfer the function, how to execute this, how to combine. Nothing. All you do is you write this cute little function called sum. You see this? You wrote this small little function which took two arguments and converted it to one, right? So this little function basically did that's the only thing you had to do. Rest of the things were done by the framework for you. All right. Rest of the complexities of distribution is hidden from you. Does it make sense to you? All right. So if you see, all of these things are happening parallelly. Okay. Maybe you can think of this way. This is one node. This is another node. Okay, so up to here will happen up to here on one node. Okay, up to here, okay, happen on, let's say there are two partition 1 and partition 2. Okay, just for hypothetical reason. So this will happen on node 1 where the partition 1 is located, and this will happen on node 2. And you, from where you have launched Spark, this function will be called, this particular part which is combining these two values will happen on the local node where you are working, where you've executed PySpark. We call your node as driver node. Okay? Driver node is the one where you are launching the program from, where the collection is happening. Distribution of work happens, but once the distribution finishes, when individual node says, hey, I'm done with my work, then somebody needs to gather the data. That is driver node. Driver as in you. You are in the driver's seat, and the PySpark is your car, and you are driving the whole thing. Okay, so here you can see that this all of these things are combined together into a single value on the driver node. All right, there are a few questions. These are very interesting questions from Yash. I would like to answer those. Okay, okay. Does flat map apply the same function over and over again? No. Flat map basically apply only on the values. Here, reduce is applying on the result as well. Okay, only on the elements of RDD. Okay, so if there are n elements in an RDD, okay, so your flat map function will be executed only on the RDD elements. Okay, not on the result of the flat map, while reduce is being executed on the output of the reduce as well. Okay, now next question from Yash is, how do you solve next word scenario in Spark without getting data from all the nodes in a single place? Again, you form something called key value pair. I'm coming to that one. And then you do a reduce by key, and that should bring all the records together for each single one. Okay. Okay, so let me try to show you. So, all right. Did I miss any other questions? All right, feel free to ask questions because that's the only way to learn. All right, so this is an example of some function. Let's say we are computing line lengths. Okay, we're computing line lengths. And if you are on a single machine, if you are using a single machine, you would be able to do this in a single shot. You will just iterate over and over, and then you will just compute the sum of, uh, let me just use Python sum function. You can see the answer is 62. Okay, you could simply say this, right? Now let's think about computation of line length and then computing sum of line lengths. All right, is everybody with me? All right. With this question, is sum also an action? No. Sum is just a function. Reduce is an action. Reduce is an action which uses your sum xy function to compute overall sum. Okay? So reduce is an action which calls some function again and again. It is the reduce which is causing it. All right. So if you think about this particular problem, okay, if you think about this particular problem where you are given, all right, I'll do a better thing. Okay, I'll do a better thing for all of you because these are the most important aspect of Spark. If you can get this, you can solve almost every problem. Rest is just libraries. Okay. So imagine the problem statement is given a huge file, find the find the sum of all lengths of lines. Okay, that is the question. All right, that is the question. Or or let me just think of okay, in very simple way, it's quite straightforward. If you are on one machine, the traditionally all we did was we load the line lengths, we iterate over the lines, and just compute the sum, find the max. Right? Find the max. Right? It's pretty straightforward, and the answer would be simply 62. Yeah. Okay. Now imagine you have to do the same thing over a cluster. Or imagine that this file is really, really huge that you cannot load it into the memory. Then what would actually happen? Okay. So, so what would actually happen when you load this file into an array in the network, into an array, and then into an RDD? Okay, when you load this file directly into an RDD, this file will be divided into parts. Some elements in node 1, some elements in node 2 and some elements in node 3. You can see that these elements went to node 1, this element went to node 2, and this element went to node 3. These are hypothetical because partitioning will not be exactly like this. Most likely this will have you know, all of these will have two elements each. Okay, just for the argument's sake I'm doing. So we have three nodes. The RDD on node 1, so RDD is divided into three nodes, some part here, some part here, and some part here. Correct? Next is that we write a flat map, we write a map function which converts the lengths of each line. So the map function, our map our map transformation would convert each line's length, right? And next, once we have this new RDD called line lengths here, line lengths here, then we execute reduce function. Then we execute the reduce function to compute the summation of all the lengths. Okay, then we execute reduce function to compute the summation of all the lengths. And what will happen then? First, 11 and 9 will get combined into 20. Then 20 and 4 will be combined on node 1. Similarly, on node 2, there is nothing to combine, so 14 will remain as such. On node 3, 20 and 4 got combined. Now, these three values, the outcome of the summation of every node, node 1, node 2, node 3, will be taken to the driver node. Driver as in your node from which you are executing this all logic. Right now, the node called H5 from where I'm executing all of this logic, this data, these three values, after node 1 has finished their work, node 2 has finished their work, node 3 has finished their work, after they have finished the work values will be taken to the driver node, and then again the same reduce function will be called. So 24 and 14 got combined into 38, and 38 and 24 will get combined into 62. So you can see that node 1 was working parallelly to node 2 and node 3. All of these nodes working parallelly and getting the work done. Okay, and once they finish the work, then all the values from the 3 node came to you, and again you executed reduce function again. You as in the driver node. So you can see that the reduce function or the action did not only get executed on every node but also got executed on the driver node from where you are executing the things. All right, so that's how it works. All right, should I show you this one? Let me just write down the code. So you have to quickly help me. So first I am saying lines rdd equals to sc dot text file, and what was that? Data slash mr slash word count slash input slash big dot txt. Okay, next is once we have loaded the file into an RDD, the next thing is for each line, let's compute the line length. Okay, we call it line length. Given a line, it will just return length of the line. Next is the LLRDD equals to lines.rdd dot map. I'm sending ll as the map function and saying let ll converts line into the length of the line. Okay, let's just first test it out whether this function length actually works or not. This is an internal function I'm trying to use. Yes. Okay, next. No, we are not splitting. So by default, when we load a text file in Spark, by default, each element is a line. We don't want to count number of words. We are counting number of length of lines. Okay. Next is, we don't need to split right now because we are just counting the line length. All right. In case you want to split it into word, then you have to use flat map. Yes, we don't need to parallelize here because it directly, as Spark provides directly a function which can load the data from HDFS into this file. Okay, we are loading from HDFS into RDD. So we don't need to parallelize. Parallelize is for the case where you have the local data and then you want to send it to the cluster. Right now we are asking Spark to load directly the data. Okay, now once we have computed the line lengths, now this LLRDD will be an RDD of integers because it contains line lengths. Next is, let's do the summation. Okay, let's do the summation. Let's do the summation of the two functions. So we say x comma y and return x plus y. Okay, and then we say total line length equals to total line length RDD. Just for the convention, I'm keeping the name RDD so that we don't get confused. There is no mandatory condition that we have to use RDD in the name. Okay, so we could say reduce, and we are passing sum in the argument, and then let the magic roll. Now we go here. It says LLRDD is not defined. Okay, let's try to do it again. Okay, then we say okay, then again, then again. All right, so it did finish this. So this is the total line length of big.txt. Okay, ideally you will just copy paste all of this into a Python program and pass it to PySpark and it will execute that one, or Spark Submit. Spark Submit will also do the same job. Alright, so that was a little interaction with Spark and that should be good for you. Okay, that should be good enough. Alright, alright, so Spark sends broadcast variables. So other than the core transformation and action, Spark also provides broadcast variables with which you could send data to all the nodes. Okay, this is similar to distributed cache. Similarly, if you want to continuously report progress from all the nodes, or you need to do the counter of all the things which are happening in real time on all the cluster, while your node are busy doing something, you want them to continuously report to you some value, some output you want. Let's say every time a map encounters a special keyword, it needs to inform you so that you can display some kind of progress to the users, right? In that case, you use accumulators. Accumulators provide a way to continuously report to driver node, because let's say you executed a map function, it's taking 10 minutes to run the map function on all the cluster, on every element, against every element is taking time, but you want some progress, you want to report some progress. In those cases, you use accumulator. Okay, accumulator can only be associative operation. Okay, they can only be additive because there is no guarantee of order. There is no guarantee of order. All right, so this is an example of word count. You must try it out, and here we could simply make it a little more. Could say data slash word count, not word count, data slash mr, okay, slash word count input.txt. This is for word count. Okay, so first you loaded it, then you split it into words. Now you got the words, then you convert it into key value. Okay, key value is nothing but a tuple. And then you used another action which we did not discuss, another action called reduce by key. Reduce by key would group the data based on the key and then apply your function called summation on all the values again and again until all the values for each key get reduced to a single value. So this is classic map reduce. Okay, so reduce by key. So what is key? We convert our word into key and value like this. Okay, each word is a, you can see that each word is a key and value is one. That's what the 2kv did. This function 2kv converted our individual words into a pair. This is a pair. Okay, and then once we have created a pair, we simply said reduce by key. Reduce by key will pick up every element from an RDD. It will assume the first value of the pair to be the key and will bring all the values for each of this key. And once that is done, for it will combine all the values together using your function. Okay, so let's try to see if we can execute this. Okay, so now let's try to see if it works or not. Okay, you can see that we have been able to count the words. Okay, the empty one, it has occurred 70,000 times. Now let's save it to let's save it to my output folder. Okay, we call it Spark MR out on 12 December. Okay, now we are saving it. We are saving it to this file. All right. Is this clear? So reduce by key basically does the grouping and then reduce by using this function. Okay. It says the job has finished. The data has been written to this folder. We can see this data by going to hue. Okay. By going to hue. You can see that. Okay. So two parts are created because there have been two partitions of the RDD. You can see that the counts have been computed. Okay. All right. You could do the cleanup of this data in the another map phase or in this same map phase here. When you are splitting the data, you could clean up or you could apply one more map phase. Okay. Now Yash's question is how to sort the values within the key. Okay. You can sort the values using either the what do you call within each key you cannot straight away sort the value key sort the values. Okay, what you can do is you can just create a map function, create a map function which will be applied to all the elements of an RDD, and every element will have the same key. So okay, let me just answer yes its question. Okay, so let's say there is a group by key function. Okay, you had this RDD equals to sc.text file. Okay, and it has some file name here, and this is called, let's say, lines. Now we created, say, words out of it the way we have done above. So now words RDD is words RDD. Okay, for each key we want to do kind of sorts within the value, right? Now what you do is you first create groups RDD by saying words RDD dot group by key. Okay, first you create tuples or creates key value pairs, create key value pairs using map. Okay, you create key value pairs using map, and then after you have created the key value pairs, then you say group by key. Now group by key will be RDD which contain every element in the form of key and values. Values will be an array. Now you could use map again, and inside map you could sort. Okay, so the question was how to sort values within a key. Okay, so simple is you use map, and then inside map you could use Python's inbuilt sort function. Okay, and finally you just reduce, not reduce by key, because you have already grouped it by the key. All right, good, good. All right. So, okay. So Mithili is facing a little bit problem here. So here, make sure that you, when when typing this, I'll show you. I think that'll be better. So when you say some function, I'm typing this. Define my function. Bracket is started, some value, bracket closed. Then I'm typing colon, and then I'm pressing enter here. After pressing enter, Python demands that you put a indentation. Indentation could be tab or could be set of spaces. Okay, so here I have pressed tab, then typed return space x into 2. That's what I've done. Now you can see it is working fine. Even if you do not provide semicolon, it's completely okay. All right. In your case, mostly you have not pressed tab, and that is the reason you're getting an error. So indentation is a little problematic with Python. Okay. And I somehow like the idea of indentation because it forcefully keeps my code clean. All right. So that's about. Okay, Biswa's question is if I use sort function of Python in a user-defined function, this would run in every node and sort will happen on individual nodes. How would I get sorted order on overall dataset? If you want to do this, so here the previous case where I was discussing, okay, so we were saying reduce by key and then passing the sort function. That is also kind of distributed. Okay, the map is also okay. How should I? Okay, all right. So the case I was explaining here, that you can use Python's internal sort on each key. Yes, there definitely I'm trying to run sort function on all the values in a single shot, right? On all the values in a single shot. Okay. In that case, the reduce function would be able to help you a little better. Okay. So again, I think yes, you are right, Biswa. You're right. Let me try to attempt to answer my previous question again. Question was, okay, question was how to sort within a key. How to sort within a key. Okay, so you could say, let's say you have key words, key value RDD. This is your words, key value RDD. Okay, this is words key value RDD. It contains something like, I'll try to explain it in this manner. Let's say Sandeep and Giri. This is my key value RDD, some key value RDD, and say Sand, and then again we have Sandeep, and say here some Bansal, or something like I have Sandeep and then I have Singh. Okay, so I'm just giving you an example, and we have Biswa and we have Mishra. Okay, so we have this kind of model where we have I'll just put sc.parallelize over this array. Sc.parallelize, I'll just take this array, convert it into RDD, and here we are. Okay, so here we are. Now what we want to do is we want to sort the values within a key. Okay, so what we will do is, okay, mhm, it's going to be tough. All right. All right. So ideally, inside the reduce itself, we could sort the values. Okay. Inside the reduce itself, we could sort the values, but that would require a little bit more than what we are thinking. So there is actually, yeah, sort by key. Yeah. Where is the So basically you could use a function called sort by key, which takes key and the value, which takes a function, okay, and that function can define how to compare the two values, like you did for the comparator. Okay, so you could define your own comparator, and then it'll sort first by the key and then by the values. Okay, or you could group it, and if you group it, the problem is then you will get a single array containing all the elements, and then inside each element, if you have to apply sorting, then you will have to, that is non-divisible. Each element is non-divisible on multiple node. Therefore, if you do the sorting inside one, it is going to be difficult. Okay. All right. So you can take a look at all other functions provided by Spark, and you will get a fair picture when we talk about this. All right. So the function that would solve your problem is most likely aggregate function. Okay. Aggregate function basically is similar to reduce, but it solves the kind of problem you are talking about. Okay. So there are many functions you can see combined by key. So for each combined by key, what needs to be done together and so on. Okay. So you can see sort by key is there and so on. Okay. You can define a key function using which the sorting will happen. All right. So yes. So yes, question is, but for the final piece of logic where I find three most occurring words, I guess we need to have all the outputs in a single place. Kind of true. That is right. Okay. But a lot of it could be handed over to sort by key and other things. So he's talking about the word suggestion problem, Biswa. So there you have to bring all the following words together based on the first word and then find the most top three occurring words. All right. So, all right, take a look at this list. That should be good enough. Okay. And next is, okay, we talked about this. All right. So I would like to quickly take you through the streaming. Okay. Take you through the streaming. And in case you want to get into the details of streaming, just let me know. I can share with you my demo on Spark streaming to the other batch. Okay, with a Kafka. With Kafka, I've done the demo to other batch. So if you want, I can just give it to you. The one from the Spark batch. We have a Spark separate course, so I can share with you the demo. All right, let me give you the overview of Spark streaming. All right. All right, so you must be hearing a lot about streaming this, streaming that, real time, and all that, right? And even when the discussion on big data started, we talked about something called velocity, and this is that velocity part. There are two aspects of velocity. There are many more examples of velocity. One is load balancing, when you have lots of data coming in, and you have to balance the load in such a way that you are still able to do the computation correctly. Okay. Other aspects of the velocity is you have lots of data coming in and you want to do the computation in real time. Okay, so here sometimes it becomes like volume, velocity, and variety, all the three things in a single shot. That's where the streaming solutions come into play. The streaming is heavily misused word. Okay, watching a movie at Netflix is also called streaming, and watching something on YouTube is also that. And we, while talking about Unix commands, okay, like sed, okay, like sed, or when we talked about unix commands, then also we talked about streaming, because sed's full form is stream editor. Okay, so that's the second interpretation of the word streaming. Third interpretation was Hadoop streaming. Okay, and fourth one was pig streaming. Okay, where we were streaming data through a udf, through our own script. So these three, Hadoop streaming, pig streaming, and SED, they are similar in nature because we are passing the data passing the data through a command passing the data through a command. Okay, the fourth interpretation is stream processing. Stream processing, and that's what we are going to discuss. Okay, that's what we are going to discuss. The Spark streaming is one implementation or one solution to this streaming problem. Okay, let me again take a step back and try to okay let me again take a step back and try to explain what does it mean by stream processing or Spark stream processing. All right, so I was working with a company called Dell. You must be knowing that. So I was just consulting with them. They generally come over to my place and discuss their problem. So we solved their problem on something very interesting. So they have an e-commerce portal from where people buy things, and what happens is whenever somebody is buying, there are a lot of things happening. Instead of instead of putting all the logic, say fraud check, say delivery notification, and all of there are many things happen the moment you click on buy now. There are a lot of things happen in the background. Fraud teams get notified that please check the transaction fraud, whether it's fraud or not. Then delivery team is informed that please deliver this item, and then the courier team is asked to give the status updates on a particular on the delivery thing, and so on. There are so many things start happening parallelly. Okay, so instead of all of this happening in a single piece of code, there are the nice mechanism, something called queues. Okay, all of you must have used queues. So what we do in the queues is that whenever something happens in an organization, we put in the queues. Okay, we put in our queues, and whosoever wants to listen to the queue, they can listen to the queue. And one single queue in an organization, one single installation caters to the whole organization. Me and you want to talk about, say the classes. Okay, so we'll have our own queue inside this software, and the people who are talking about e-commerce, they will do so the notifications of purchase will also go into that. So these queues make a big use case in any organization. Okay, the quality of a queue is you can put the data into a sub queue, into your own queue, and it immediately can reach the listeners. There could be multiple listeners to a single queue, and there are multiple speakers on a single queue, meaning multiple people can broadcast to multiple people just via the queues. Okay, and the other important part is that most of these queues are built for concurrency, meaning multiple people listening to the same topic would not corrupt the data. In case if somebody has read the data and forgot to delete, or had the process has died, so all of these cases are very well handled. Okay, so similar thing I was doing at Amazon also, like what I did for Dell. So in case of Dell, what they wanted was that these events that are happening across, that one laptop got sold, 10 more laptops order got placed, and and so on, the laptop is being assembled, and all of that keeps on happening in parallel. Now what they wanted was in real time, they wanted to show to the users, they wanted to show to the upper management that what is the progress going on, how many laptops are yet to be processed, how many laptops have been have been handed over to the courier guy, how many how many laptops are in the assembly line, and so on. They wanted to see it in real time. Every second things keep on moving. Okay, so basically all I had to do was I had to listen to all the events that are happening in their organization. Listen to all the events and count number of events in each bucket. That's it. All I had to do was count number of events by their bucket ID. Okay, every event has something called the status, and based on status I had to group all the events and then say that these many events are occurring per second per bucket, so some sort of that kind of combination. And I had to show it on the UI. So one of the student was working on it with me, so we were able to successfully do that for them. Okay, so and how did we do that? We used Spark streaming. Okay, we used Spark streaming, and in the same way you could read from, they had their own queue. So what we did was we pulled the data from their queue. We asked them to push all of the data into our Kafka. We had Kafka queue. Kafka is one great queue. I have studied many queues so far. There was MQ, and there was at least 10-15 queues I have reviewed, but Kafka seems to be the most powerful so far. Kafka is a distributed queue and is well integrated on Yarn. Okay, so there are many solutions which produce data rapidly. One of such solution is Flume, other is HDFS, other is 0MQ, and you could have your own Twitter downloader. Okay, so which is continuously reading data from Twitter. Now the data that is coming at a very fast pace from these solutions need to be processed, and then output is saved in any of these places. Okay, so there are many solutions for Spark. There are many solutions for streaming, and Spark streaming seems to be more suitable well, in lots of cases. When I'll compare later on when to use when. All right. So what happens in case of Spark is the data that is coming per second is pushed to RDD. RDD is Resilience Distributed Dataset. So the data input stream that keeps coming at a very fast pace we keep on pushing it into the batches of input data into RDD. Okay. So okay, let me put it this way. So when we talk about Spark streaming is a very thin layer on top of Spark. And what this Spark streaming does is we tell Spark streaming that, hey, read the data from this socket. And it goes and reads from that socket or read from that source. And what it does internally is per second or per whatever window we define, per second it reads the input data and creates RDD out of it. It creates an RDD out of it, and whatever program you have given to Spark streaming, it runs that program against that RDD, and whatever is the result, it keeps on saving into a folder. It is as simple as that. So you write your program using the same flat map and everything, assuming that there is some input RDD on which you are running your code, and then hand it over to Spark streaming API and say that, hey, can you execute these things? Okay, and this Spark streaming reads the data parallelly per second from the source and keeps on creating RDD, and for each RDD it'll keep executing your logic, and your logic will, and whatever is the output of your logic, it keeps saving into the output. And that's what is Spark streaming about. Okay, so workflow is, yes, so the final job gets triggered for every second. So whatever you write, that'll get triggered every second or so. So the workflow is Spark streaming receives live input data streams. It divides it into batches, and each batch is nothing but an RDD. Okay, it's nothing but an RDD, and on RDD it runs your logic, and whatever is the result, it pushes it to the disk. Okay, all right. So you can see here the upper half, you can see internally this is what happens. On one end, the data is coming in, and internally it's creating RDD at time 1, RDD at time 2, RDD at time 3, RDD at time 4. Okay, each RDD, and this whole thing, the composition of RDD is called D stream. That is the only object Spark streaming provides. This D stream is an abstraction of representing the temporary RDD for every second. So you code against D stream, and whatever the code you write, that code is going to be executed on every second RDD. Okay. All right. The Spark streaming, other than dstream, provides one more thing called windowed operation. Sometimes you want to combine RDDs from multiple time stamp, multiple time window. In that case, you can define RDD like this. Okay. So original dstream containing many timestamps like time window 1, time window 2, and so on, then can be grouped into one. All right. Let's try to show you an example. All right. So I think a better would be if I think I would share with you my another demo. That will be easier because that it'll take maybe an hour for me to get into this. So, but I'll just walk you through the workflow, and then you can take it further. So basically, first you create a connection. Okay, then you code against the D stream saying convert my line into words and so on, and then you for each words you do the reduce and group by. This is Java code. Okay, and then you say word dot collect, and that should give the results. Okay, so the output of the stream word count is that lines from time 0 to 1 will print the one word count, and lines from 1 to 2 print something, and so on. Okay, so this is how Spark streaming works. All right, so I'll share with you my another demo which I did last one, because it'll take me maybe 1 hour more. Okay, Mamta's question is, will there be a scenario where data in time 1 and data in time 2 be the same? Maybe it could be same. It all depends on data generation. So the example which we will be taking interestingly is this will be consuming output of a command called yes. And what does yes does? Yes basically keeps on typing y. Okay? Yes basically keeps on printing on the screen as y continuously. And we generally pipe the output of yes to any installer so that it keeps on pressing Y to all the questions that installer asks. Okay, it's like saying agree to every terms and condition. All right, so when we take an example of word count, I use this command called yes to generate a continuous stream of data. This Y command generates continuous stream of data. Okay, or I think the other way to continuously generate data by calling dev random. There is a way to read the data from random. It generates random words. Okay, so yes, in that, even in our example case, all the windows lines from time 0 to 1, all of these windows will have the same data inside them. All right. Was that your question? All right. All right. So we will discuss the other things tomorrow. That was pretty much about Spark and Spark streaming. I'll share with you a hands-on example of Spark streaming tomorrow. All right. So in case of stream processing, the redundancy is definitely there, but redundancy is kept separate. Redundancy should not generate more data. Okay, for that example, say Kafka, when it consumes the data, every queue is replicated twice or thrice, and there is a copy of it kept. All right, we'll see you tomorrow. Tomorrow at the same time. Bye bye. Have a good day.